So we're going to cover ASCE's new as-installed standard, or it's a standard guideline for recording and exchanging utility infrastructure data. So it's our new as-built standard, and we've been working on this for a number of years. I'm chair of this committee for ASCE, and Eric Berkowitz is going to show a quick example of how it's been implemented in Montana. We had the standard's just about to be released. It's in publications' hands. Actually, I had a committee meeting earlier today, and it's just getting dusted up, or cleaned up for public comment. But it's a standard for utilities, for people managing right of way to use to collect data. I mean, that's the big problem with augmented reality. I think right now, I think you hit on it. We need good data. Good data going in gives you good, everything else. So this is a presentation we gave. It's abbreviated. We're going to keep it at a high level. We actually gave it for the Global Excavation Safety Conference, and I see that they're hooked up with this organization, so that's good. Give you a quick overview of the as-installed standard. Again, we're going to stay high. We're not going to get technical. And then some of the uses, which I think I can kind of gloss through because you guys did a great job showing some of the uses. And then the cradle to grave management. Why? I mean, maybe I don't even have to hit this, but utilities are a huge issue on projects, and that's how ASCE got involved a number of years ago. Actually, the Utility Engineering and Surveying Institute, which I'm part of, which is sponsoring the standard, originated out of the Construction Institute, and that's because it was a huge issue of construction. But what we've done is basically move the problem from a construction issue to an engineering problem. And why is that? Well, I mean, why we know our right of way is getting more congested. I'm not going to dwell on this. It's just basically to lay it out, but it's congested now, and it's getting more congested with our internet, commerce boom, and the 5G. And what's coming here is we're going to have a lot of high voltage DC transmission lines that are being proposed to be installed in our right of ways, and that's going to even complicate the underground scenario even more. So our work, your work, everybody's work is going to get more and more important here as we go forward. So it's an exciting time for all of us, but we're also going to have to get a little more sophisticated in how we do business and how we do things. So I applaud Barb and Steve for actually organizing this and having these discussions, because it's really good to exchange ideas and to keep moving forward. We want to get away from this, because what we've been forcing people to do in the past is design with non-standardized data, and that leads to unsophisticated resolutions in the design, and then the risk is pushed to the contractor. It's also pushed to the contract locators to have to deal with that, and then it's all reactive management, which is, everybody knows that's an inefficient way to do business. So, contractors are having to go out and dig up everything in sight. And this is a real project where, every 25 feet, the contractors excavating utilities to expose it, because that's the only way they can deal with it. They don't, they're working with garbage data. So we're trying to get away from that, which is not only expensive, but again, you're dealing with it at the construction end of things. So what we're doing is we're trying to remind engineers that you everything you do when you develop this design is impacting the public. And when you're an engineer, you take an oath. You're saying, I'm holding the public welfare paramount over all other interests. And so we want to mitigate relocations. We want to mitigate risks to the services, to commerce, traffic impacts, health and safety for the contractor and the workers. We want to mitigate the project schedule. I mean, that's a huge thing. That's a huge cost issue, and really get the risk out so that the contractor can get in there and do their work. This is all the engineer's burden of responsibility. That's why this standard was developed by ASCE and being promoted. Now we really have two standards. We're going and the one standard you may have heard of is ASCE 38. It's been around a long time, about 20 years now. and it's being upgraded concurrently with this new as installed standard. These two standards actually are sister standards. They complement each other. So 38 is for existing utilities. Oops, and I guess, and then the new standard is for newly installed or exposed utilities. So they both overlap with the exposed existing utilities. There's a little overlap there, but the new standard was set up to like, okay, how are we going to collect this data so we can basically have it in a format that can flow into augmented reality and other Navisworks and other uses, because right now it's the ASCE 38 standard was focused more on in a drawing type of format, and what we want is digital data that's in a useful format. So we didn't try to define a data schema. We just wanted to define the raw data elements and how to collect that data so that it can flow into these applications. And basically, we kind of outlined a framework for a GIS system to manage this data. So we want to outline the essential elements for recording and exchanging the data. We want it to be digital, not a drawing. We want to get both location attributes and information about that feature. And the goal is to collect enough data so we can recreate basically a digital twin of what's out there that we can, when your augmented reality does its job, it can get the size right, it can get the material right, it can get the depth right and the position right, and get the geometry. This is a big deal. We need to understand not only where it is, but how big is it? Where is it taking up space? And our standard, we actually brought in Canadians. So this standard stemmed from a Canadian standard. It was published in 2011 called CSA 250. And we had people from that committee on our committee, and they said, these are some of the things we wish we would have done. And one of them was to include the above ground and the underground with it, and to make it 3D and to make it digital. So we did all those things in the standard. And we wanted to focus on newly installed or exposed infrastructure. So every time somebody's out there digging in the right of way, there's great opportunity to get beautiful data rather cheaply. And if we collect it to the standard, which is really not a big deal, especially with the technologies we have today, it can help us. And over time, we're going to get enough data where we can really improve our knowledge of what's out there and be able to start using this data. It's going to take time, and we're also going to be collecting data from other efforts as well, not just construction and newly installed installations, but subsurface utility investigations, record data. We're looking at contract locators, even getting that data and bringing it in. There's a lot of sources of data out there, and we're going to qualify it. Another thing, like I said, we want to get away from this 2D, and this is I like to show this just because it helps. This is a 2D drawing, and we want to move into 3D. And you can, it doesn't take a rocket scientist. This is where, you get it in this format. Now your kindergartner can understand what's going on out there. And what this does is it opens the door not only for communication, for people out there working, but also your design. You can start coming up with clever solutions on how to avoid things and that's the whole goal. And we have one case study. I'm not going to spend a lot of time on it, but in 2015, this was done using subsurface utility engineering methods, but it just shows the value that's reaped with 3D. And the contractors looked at this. We did a 3D model and we optimized the alignment for a gas main installation. And at the pre-bid conference, the contractors are looking at it going, this is the best bid package you've ever seen, and they just wanted that model. They didn't want the cross sections or profiles. They wanted that 3D model, and they brought that back. And then the actual estimate was 10% below the engineer's estimate, which is, you've already paid for the whole effort to do this. And then they scheduled 10 weeks and 2 crews. They had to work at night to put this gas main installation along this busy corridor in Lacey, Washington. And we had 193 conflicts called out ahead of time. We had it all designed, in 3D, where to lay that pipe out. and everything was exactly the way we told them was. And there were, I think there were some 23 unknowns we identified ahead of time too. And so everything was so good. They were laying 300 feet of pipe a night, and they built the whole thing in 7 weeks with one crew. So I mean, that's the value. I mean, you go from, you know, what they're normally accustomed to with a lot of field fitting and, you know, running in and messing around with things, and the risk, you know, and damages and things, to where they just flew through this project in 7 weeks with one crew. That's huge value. That's where the pay dirt is, and no damages, delays, or changes, you know, claims or anything. And neither the traveling public or the commerce was affected, which is, you know, this is a clear good case study, clear cut. And it was designed as and then this is just showing a project that, you know, is in Honolulu, where they're, you know, if you have this kind of information, you know, that you can see where, you know, if you had your augmented reality, you could walk around and you could really, you know, or even if you're the contract locator and you're flagging things out, if you could put on your Google glasses and you know, you can line up with GPS over the gas, you know, you've got the, oh, I'm on the, this is the abandoned section here. I want to be over here on the live section here, you know. So, you know, you can sort through that stuff. So it, you know, this is, I'm kind of glad Troy and, well, I guess I can spin through this real quick. I don't know. Anyway, they're actually taking a 138 kV transmission line right now, and they're trying to snake it in along this road. This is in Honolulu, and this is a several mile corridor where everything's mapped out in 3D. But you can, it's a real easy step once you get it modeled up like this to push it into AR. So let's get into the standard. This is you know, like I said, we wanted to get spatial, geometry, and feature attribute, and at least a minimum. We're not trying to, you know, get everything about that facility. We want enough so that we can, like I said, make a digital twin of it and have enough for engineering, for civil engineers to understand and to deal with. And we want it in a format that could be easily transmitted. And it is kind of exciting. I'll get into it, but the Open Geospatial Consortium has adopted this standard draft that we have, and they're building it into a 3D modeling model standard that they're developing right now. And I'll get into that. But again, it's to empower all kinds of great things that we aren't doing right now. You know, there's unexploited value to be reaped. You know, in the asset management realm, in the coordination, the engineering, you know, resiliency analyses and things like that. So I think the big buzzwords right now are resiliency and sustainability. I think those are the two key things you got, and this is going to help do that. So yeah, digital project delivery. So, you know, going to digital paperless type of formats. Again, effective use between exchange between stakeholders. Machine guides, augmented reality. There you go. This is the other thing. So there's locators out there right now that have GPS on board, and it would be real easy for a locator responding to a Comcast ticket or something, and they can go out there and like I said, if they have their equipped with their goggles and their GPS enabled locator, you're gonna get it every time. You're gonna do a good job, and so we won't have the oopses we have now, you know, because it's hard. It's really hard. The more congested that infrastructure realm is, the harder it is to go out and locate things. And then yeah, we want to get away from transcribing paper drawings and PDFs. We want it all digital flowing. So, and then yeah, conflict assessments. These are things that aren't being done right now. Right now, a lot of engineers they punt. You know, they have kind of so-so data, and they wind up just telling those utilities to move. You know, get them out of the way. And every time you do that, you open a can of worms, because like, when are you going to move it? How are you going to move it? You know, where are you going to move it? You know, the EPA, I mean, you have to do, if it's a gas main, you know, you might have to do an environmental assessment, and you can only move it certain months of the year. And yeah, and we want to, like I said, with that high voltage DC transmission lines, that's to enable, you know, collection of power from all these renewable sources, and to feed these charging stations that we're going to have to install everywhere. So you're gonna, there we go. There's Troy's stuff. And this is real. And what's kind of cool with 5G going into the ground, it's going to work even better. You know, it's a little clunky right now, as I said, but it's getting better and we're getting there. And again, the key is to have good data going in. This is easy to do once you have good data. And the other is like machine guidance. And I think you saw maybe, I don't know, I think Brad had a presentation by Robert Martindale, and he showed how they're, you know, I mean, it was a mock-up, but it's basically where we're going, where the, you know, they can prevent the contractor from digging into that power line and blowing things up. The old warning lights will go on, and the machine won't even go there unless you override it, you know. So you'll so the people are involved with the standard development. We had a good array. I mean, as committee chair, it was exciting for me because we had people from the entire spectrum: GIS specialists to CAD specialists to surveyors to engineers to utilities and the Department of Defense and pipeline safety, you know, DOTs, and everybody spoke their own language. It was kind of interesting. I had to, you know, get the GIS to people to translate to, you know, to the engineers so they can understand it, and the same with the contractors. And but we all came together on this. We all said, you know, this will work. This does it. And so we all have the ballots have passed, and we're excited to actually get it rolling. Again, it's new construction. Anytime a utility is exposed, actually. So the idea is the standard can be like MnDOT or City of Minneapolis. When they issue permits, they basically say, okay, with the permit to get out there in your right of way and dig, we want you to do this. Just collect this data and submit it. And when they're getting the permit, and Eric will show you, they basically populate a lot of that information ahead of time. So you know, it's just a matter of getting a few survey shots. And you know, if you have to, you could use your cell phone. You know, I mean, it's scalable, is what I'm saying. The standard. Anyway, anytime there's construction. So the standard, here's the standard. I'm just showing you the table of contents we have, the structure of it. And we're just going to focus on a couple things. Again, I'm trying to stay high level and get fast through this so Eric can show how it's run. And I might just blow through the data stewardship part because that maybe won't affect you guys as much, or maybe it's going to take longer than I have time to talk about. But if I get into, there's a couple basic concepts to just grasp here, and I think it'll make Troy smile when he sees this. So we're referencing everything to the absolute spatial. We're having absolute spatial positioning. We're having accuracy collected with it, and this is easy to do now. It's so easy to do. It's people don't realize it. And then the framework for exchange. So we're tying everything down to what's called our National Spatial Reference System, which in Minnesota is very dense. You guys have a beautiful network of datums up there, points. And I don't know why Minnesota's so good. I haven't figured that out. It must be a lot of lakes, and the guys like to fish out there. I used to work for NOAA, so I can. We actually put a marker in a bar one time too. That was a. I'm being recorded, am I? I better shut up. Anyway, so the idea of the National Spatial Reference, every time you turn on your GPS, you're collecting lat long that's referenced to our National Spatial Reference, NAD 83 and NAVD 88, and it's but the idea is, you know, if everything's referenced to that same standard, then when you bring these different data sets together, everything overlays perfectly. You don't have this, you know, mixing this. And this is actually, I took this from NOAA's website here. And all your federal agencies are you know, they collect data to that data. The other thing, another thing we're doing is having a positional accuracy level. If you're familiar with ASCE 38, there's a quality level, and you have A, B, C, D. And but in this case, this is survey grade stuff. So we can actually put an accuracy level. The Canadian standard, they had the same table. So we wanted to be consistent with our friends up in Canada. And we have English. They aren't one-to-one, but they're, you know, pretty much compatible, you know, as far as typical units. And and these are the accuracy levels. So you could basically, as an administrator, say, hey, I want that to accuracy level 3 or better, and and then if to get that, these are rough guidelines for achieving that. You want to get like if it's a rigid pipe, we want to get every joint. That's an asset. Every joint, every weld on that, but also at least every 20 feet, and basically flexible lines every 10 feet, and all deflection points. And at directional drilling, you get the entrance and the exit points and any test pits that they drill through. And yeah, all non-segment features too. So all the vaults and the pedestals and the valves, things like that. So I might this is just don't memorize this, but just know that most everything out there that's a utility is going to fall either under a segment or a device. And then if not, then you might have a support structure, would be a pole, or encasement would be a casing pipe or something like that, or markers. So we really brainstorm. We look at all the states and all the DOTs, and we try, when we looked at their survey feature codes, and we tried to, accommodate all that. And it really came out to be a very simple process. And then again, we went to, we have both a 2D and a 3D definition for these geometry types, I guess we should say. And then again, don't memorize this, but what you'll see in here are M's, O's, and C's. And M is minimum. So that basically here we are. So we have these minimum data attributes that we capture, and with this we can turn around and create the digital twin. The extra stuff's just, it's bonus, and it's up to whoever's managing the standard to to dictate or to request what they want in addition to the minimum. And then again, the positional, the XYZ observed, and we're basically, if you're doing top center of pipe, that's being documented in there. And that enables you to readily, with a little bit of software, to push it into a 3D model. I'm going to quick fly through this because I don't think I want to spend a lot of time. I can provide the PDF of this when we're done, and people can look at it at their leisure. But we do address sensitive data. That's one. We had a person from the Federal Aviation Administration, Dick Pop, who was an expert with sensitive and secure data. And we referenced the ISO standards and the CFR 1520 for managing that. So anybody that's managing a GIS understands this. We don't have to know that. You guys don't have to know that, but just know that people talk about sensitive data, the standard addresses that. And again, here's a quick example, quick and dirty, of data getting collected on a new sewer pipe installation. And in addition, like I said, you're going to collect all the exposed utilities that cross it at the same time. Now, you may not know what the facility is, but you're going to have a shot on that. And this data is just going to go in the database, and over time, people will be able to figure, oh, that's that gas line, or that's an Urbana line that but it's going to populate, and you're going to have bigger data. Michigan, I think, demonstrated a couple of years ago with their guide program that in about 10 years, you could have a really good, with all the work going on the right of way, you're going to have a real good idea what's out there. Okay, so and I talked about directional drilling. The other thing, we are collecting the geophysical data in between. So here's where we're kind of leaning on our ASCE 38, where we've got survey shots at the entrance and the exit, maybe the test pit, and in between we're going to have geophysical data. And now we're going to fall back on our quality level B designation, if you know 38. So this, again, if I'm talking too fast or whatever, just know we got it covered here. And utility owners, they're going to get, the big thing with utility owners is we're going to enhance their damage prevention and reduce their risk. And the other thing is they will be able to use that data when they're doing their own planning. The incremental cost is not a big deal. A lot of utilities are already collecting as-built data that's just not standardized. And we're just tweaking what they're doing to get everybody to line up the same. And let's see here now. Yeah. And I think new installation, but oh yeah, like I said, they'll be able to use that data for their own projects. So that there's a huge value there. So we know there's a big return on investment by doing 3802. The study was published last summer by the National Cooperative Highway Research Program, Task 418, and we just kind of came up with a rough, using SUE as their guideline, about 10 times the return on investment that you get from SUE. So by starting to collect as-built data at the time of installation, that's the best time to get it. It's when that utility is going in the ground, it doesn't get any better than that. Once it's covered up, now you're starting to get, you're reduced in what you can do. And as I mentioned, OGC has adopted it. What they're doing is developing a 3D model that, if you can picture this, say the gas company collects it in that data, they'll have their model in their own, secure wherever realm. And then you're doing a project or you're doing a locate or whatever, you basically you get access to that little bit of information in that area. You can go out there and put on your goggles, you can bring it into BIM, you can do whatever, do your work, they can live reference it in. And then when they're done, they can turn it off and it's secure again. So that's kind of one angle. Eric, I'm going to turn it over to you now. This is he's going to talk about how Montana is doing it, and this got an ASCE award, so and it went to nationals too. So this is hot stuff. Go ahead, Eric. I'm going to stop sharing.
Okay.
How do I stop? Oh, there. Stop here. There we go.
Okay, I am going to take over, and thanks, Phil. And yeah, Nick and Troy, that was good and interesting, and we've kind of seen this stuff before. We're going to take a little bit of a different tack here and really talk about how you can manage this data. So our whole goal too was not only being able to create these models, but how do you manage that information? Where does the data come from? And what's the process to do that, or what is a process to do that? So before you put anything in the right of way or in somebody's right of way, you typically have to have a permit. So what other better way to manage this whole process of getting that information is to do it through the actual permitting process. So we at Utility Mapping, the company that Phil is the president for, partnered up with an Italian company that already had a WebGIS based permitting system integrated, where they had started to integrate a data repository into that. And so we consulted with them on developing that and modeled that data repository after the standard that was being developed. Not quite signed yet, but that's where we were. And can everybody see my screen?
No.
Oh, sorry about that. I was talking away.
You.
All right. How about now? Can you see it now?
Yeah, there it is.
Excellent. All right. Sorry about that. So I won't spend too much time on the actual permitting process itself, but I'll kind of step through it a little bit. It's a WebGIS based program. So you just use a web browser to access it. You don't need any special software on your machine. And this kind of handles the whole process from beginning to end through the environmental review, traffic review, subject matter expert review. Everything is kind of handled in there. And also the utility management portion of that, and getting as built or as installed data into the data repository. And I'm going to focus on that mostly. But so they've got just a little login screen. They go to MDT has a landing page. You click on their little link here and it takes you there. It's got manuals about how to do everything and announcements and stuff. Any updates to the system are announced there. The applicant comes in and they get a listing of all of the work that they've got, either work that they need to follow up on, or just a listing of all the applications they've sent or submitted. And they can see the status of where they are. Is it under review? Has construction started? What phase of the process are they in at this point? And what it's done for them is nice because they can see it. Typically it was a black box. I emailed my application in, it went to somebody, they were reviewing it. I had to ping them on an email, hey, where's my permit? Things like that. Right now they can see exactly where it is within the system at a glance. And it's really helpful for them. It also automates some of the processes and procedures they had to do before, like figuring out what section, township, and range they were in, what roadway they were in, what mile marker they were working from. The system is integrated with other GIS layers through REST services and other ways, and it just queries the background GIS layers and pulls that information into the application for them. You can kind of see a little bit of a listing of that, and they can use each of those columns to search on specific fields. Like if they want to just see all the permits in Missoula, they can type in Missoula in the city and it'll filter all that stuff. So pretty simple stuff. For the DOT, they have additional dashboards. They've got a geographic dashboard. They can see all the permits across the state. The different districts can have their own that just shows their stuff in their district. The geographic dashboard also has a listing of all the permits that are in the system as well. Great again for MDT and the applicants. They can see exactly where their permit is in the process and what's the next step and who has it actually too. So that's kind of a quick kind of intro of it. But the main point is there's a utility location data repository on here, a ULDR. It's a 3D database. So it's also built on the standards that Phil talked about. We'll go into it a little bit. I won't go into a whole lot of detail. And this is, again, very high level. But what we're going to focus on is the process of getting that information into the database. Now, we're really interested in all these cool 3D models, this augmentation and stuff like that. That's great. That's kind of the end product. We want to try and maintain that information and data so you can create those models when you need them, right? And you don't always need to have those models on hand. But if you maintain the data in a standardized format, it's easy to create, easier to create those. And if you manage the data and information that gets in here, you can attribute it properly so you can start to make those engineering decisions. Because we're going to collect, as we'll see, or we'll talk about a little bit, not show too much, but the surveyor is responsible for attesting to how accurate the information they collected was. So there's a whole review process that goes on with this. But the main focus is what's the process to get the data in here? It's pretty simple. Here's kind of the workflow. So I've got the applicant, the utility company or the applicant, they'll come in and they'll draw their basic project limits of where they're going to be working. Where are we going to be installing this utility? They'll submit that and it goes and queries the database, the data repository, and says, hey, are there any utility in this project limits? And right now there's not a lot, right? We're just started this. It's went live in January of 2020. So we're a year and a few months into this thing. So, but the first step is, hey, is there any utility data in the project limits? If not, it automatically approves that project limit for them. If it does find utility data in the repository, it has to go to MDT. MDT has to make a decision whether they're going to release that information to the applicant. Do they need it for their project? Typically, yes. If they're installing a utility, they're probably going to need that data and information. They could use that information in their design. And again, it's all 3D information that's been acquired, horizontal and vertical information, also accuracy. How accurate is that information? So after the next step, and I'm going to talk through this and I'll kind of show you a few little slides about it. But so the next step is that they go and they put the utility design in. You can either import it through a shapefile, a CSV they can import as well, or they can draw it on there. And right now at this point, we're not really too worried about the accuracy. I mean, MDT wants to know if it's in the right of way or not in the right of way, obviously, but exactly where it is isn't that critical. But what we're starting to do is build all of the metadata and the attributes about that utility. What's the material that you're going to use for this utility? Is it encased? What size? Who owns it? All of that other information that needs to be acquired or added based on the standard to go in there. And then it goes through the permit workflow, which I kind of talked about for review, traffic control if they need it. Are they attaching to any MDT structures that needs to get approved by somebody else, subject matter experts, environmental clearances, and things like that. Goes back to MDT at this point. They'll review all the information provided by the applicant. If there's issues, they can send it back to provide more information. They can upload more detailed drawings if they want of other things, non-utility features as well involved with the project. Once the permit gets approved, there's a process in there. They mark who their contractor is going to be. The contractor has a role and responsibility within the permitting system, but it's pretty simple. They basically go, all right, we're going to start work. It notifies MDT that they've started work. It also notifies whoever they've identified as the surveyor that's responsible for acquiring the as installed data. And so they can start to coordinate their survey operations with the construction company or whoever's managing the project. They go out there, they collect their data, they upload it into the system. Typically through a CSV, they can do a shapefile as well.
You might have to step it up, Eric.
Yeah, right. So they'll attribute all of the survey stuff. And so after that point, goes back to the applicant or the utility owner. They'll review it, send it back to them if there's missing information. They'll merge that with the design information. So it brings all the other attributes to there, merges it with the accurate positioning information. And then it goes back to MDT. They'll take a look at it. If they have problems, they can send it back. If not, they'll upload it into the ULDR. So what the point I was trying to make here is that there's a whole review process. The data just doesn't flow directly into the ULDR. It's verified and reviewed before it gets in, making sure all the required attributes are there. So just quick, I'm going to just kind of jump through these steps real quick. So project limits, they just draw them on a map. Here's where we're going to be working. Queries the ULDR to see if there's anything in there. For this particular one, there was some utility. This is kind of test data. Not real, but it found some data in there, and it takes it basically to the next point that they have in the database, and then pulls that into their project limits. They can download that and use that information for their design. They come back in, they put in their design, and then they start to put in the attributes. And again, Phil talked about this. These are the attributes defined in the ASCE standard, right? Size, material, what type of utility it is, what's the subtype. They put all that information here in the design phase. Again, just another shot of different components and or attributes that are standardized based on the standard developed by ASCE.
It's all pick menus, so it's pretty easy.
All pick menus, just a drop-down list. And these can be updated by MDT later on if they want to add different values or different things. So I'm going to skip to the surveyor. The surveyor's gone out. He'll come in, he'll upload his data. And what I want to just point out too, he just doesn't upload it and walk away. He's got to certify that the data that he's uploading, and he has to tell it how accurate each of those observations are. And he has to certify or attain to those accuracies that he's uploading. And then
if that's required, yeah.
It's required. Yeah, they have to do this point. So you're not going to get, we're trying to control again, what we're looking to do is control the accuracy and the information associated with that. So when you do go to these augmented reality views and or to the design, you can make some real decisions. Each observation has an accuracy associated with that. Or if it comes from SUE, it would have a quality level. How did you get there? So you can start to make some decisions about how well do you know that information, and do I need more information? Do I need to get a test hole on that or something like that? So anyway, the surveyor uploads it, goes back to the utility. Now this is kind of, it looks complicated, but the system sort of sets this up. I take my design, I want to merge it with my survey. It pulls the attributes together, keeps the horizontal and vertical positioning and all of the surveyor information, combines it with what the utility put on there. And then it goes back into, again, final review by MDT before it gets uploaded into the database. And then they have an accept and publish the data into the actual ULDR. Then it makes that data and information available for the next applicant who has a project in that area. The MDT system right now is focused mostly, actually right now, exclusively on as installed or as built, but the system could take SUE data, and typically on a SUE project, you've got pipe and cable locates, typical 2D surveyed out there in the field. You can get additional information, GPR, TD, EMI, acoustics, but basically what we can do is start to add onto that 2D, that vertical information, and create that 3D model or 3D data associated with that, so you can create those models. Phil mentioned exposed utilities during construction projects. We could ingest digital records from CAD systems or GIS. One call locates. There's a lot of companies out there now with integrated GPS with your locates. You could pull those in as well. And then inspections as well. Somebody goes out and do an inspection. Hey, inspector, why don't you take your GPS out here, get a position on that. We don't have one, and bring it into here and start to manage that. So what we're, again, focusing on is not those products per se, but managing that information and data so you can create those products at the end and use them for engineering and design. So that's kind of it. Hopefully I made it through. I think we had a couple extra minutes.
I think that, yeah, a good point too is once that data is in there, the uses of that, the access, you know, that data can be accessible to, you know, a contract locator or
Oh
I
yeah,
mean, it could flow out. You know, the
you
utility
flow
can
out.
access it. Yeah, it's the idea is to make it useful.
Yeah.
Collect once, use many times.
Yeah, this could be augmented by, you know, integrated with a 811 system where it queries this database as well.
Right.
There's a couple of challenges with managing all this, but you know, those are not insurmountable at all. So that's it for us. I think I don't have any more slides or anything else. We can open to questions if we have time. I'm not sure. But.
You guys touched on you know, price point, you know, to do this added services not being a big deal. That would surprise me from my experience working with utility companies and others as a contractor. Do you have any like more experiences you can elaborate on that not being a big deal? Because this would absolutely, you know, force our company to increase our rates to collect the data in this format. That being said, I'd love to.
Yeah, I think Phil might have some more. I mean, but yeah, the front end or the, you know, it's much cheaper for everybody involved to get it while it's going in versus sending somebody out there to go find it again and paying them. Now, the utility company doesn't have to pay that, but they wind up paying it in relocations and everything else. Those costs are going to get.
Yeah, you don't have to sell me on that. I'm in agreement with that. I'm just was looking like in real life applications where this has gone through. Have you seen it go well, or has this been a real heartburn spot?
You know, it's I want to say the equipment is going to be developed. I mean, we've talked to Vermeer, you know, I mean, most of these trenching outfits, they have GPS hanging off them, and it's just a matter of calculating the position of the cable with respect to the GPS receiver, getting the offset information. So, and as Eric said, all that attribute information is already inputted. I mean, that's been inputted by the utility. So that data is all there. The rough alignment's there, and all the contractor needs to do is just upgrade it with actual observations. And it is scalable. I don't know if that point came across. So if right, I mean, it may not have to be certified. I think in Montana they're relaxing that requirement right now. Is that right, Eric? Or
they had originally. You know, when we first developed the system, we were thinking everybody was kind of thinking a licensed surveyor would have to sign off on it. The utility companies did come back and say, hey, you know, we've got surveyors on board. They're not necessarily licensed. We'd like to be able to for the company to self-certify or have our surveyor certify that. And there are two different certifications. Now, I think we haven't answered the question yet. I think as far as, you know, what's the real cost? Have we seen a lot of pushback? We've seen a little pushback in Montana from some of the utilities, but I think the opposite side is they've really the permitting side of it has improved vastly for them. So it's kind of it's helped on one side. The requirements have been up. They're still getting used to it, and I don't know exactly how much more they're charging rate wise or per jobs or, you know, the contractors for the installation. Yeah, I don't have an actual number for you. But the pushback has been minimal. I would say we haven't had a whole lot of folks come and say, we're just not going to do it. One, you know, the right-of-way owner has a little leverage here. I mean, in order to use this right-of-way, this is what we're requiring you to do. But yeah, there's going to be pushback, and it's going to be hard, a bit of a challenge for the operators. But in the end, it benefits everybody. Just kind of convincing everyone of that and getting to that point.
Got it.
It's the basic change.
Yeah. Change is tough.
And you have what you call cave dwellers or citizens against virtually everything, I think, or whatever. I can't.
Phil, can you comment a little bit about the standard of the sharing the data? I don't know if I heard much about that in your piece.
That's a good question. So the data, just about every infrastructure is considered, kind of proprietary or confidential information. So the way Montana is doing it, they've got it in the ULDR. You have to have a good reason to have access to it. You have to have login credentials for one, but and then I think isn't that right, Eric?
Yeah.
You have to have a reason to have it or access it, but the idea is the data is in a format that's easy to exchange, though, when it's required. I guess it's I'm not sure I answered that, Barb. Exactly how.
I didn't know if there's anything in the specification or the new standard about I know the format of the data, but how it could be shared or anything about the techniques to sharing or the web service to share or any of those.
And we didn't get into that. That kind of got beyond the scope of the standard. Basically we just want to identify the data fields that we needed and standardize those. So it is kind of cool because you have what in the GIS world they call it a domain. It's basically a list of pick menu items that you can pick from, and so that's all standardized. So now the data fields are all nice, neat for going elsewhere, organized.
Thank you.
Mm-hmm.
Phil, did you spend much time with the dealing with the nature of the sensitive security information, and did that seem to give the utility operators sufficient comfort?
Eric,
is that something that really wasn't addressed by your group?
Yeah, we in the data, we call it the custodian section of the data or the standard. We talk about what they need to comply to, which are established CFR and ISO standards for keeping the data secure, sensitive and secure data. Eric, how did the utilities respond as far as having this data flow into this repository? Was there any?
Well, the telecoms are pretty tight about what information they have, and MDT's still push was to know where stuff is. They can relax some of the information, maybe the size. We don't necessarily have to record the fiber count that's there. So there's some information that is optional in the standard, and the main thing is, hey, there's a communication line there. That's what we need to know. If during design and construction and they need to start making decisions about that, again, what we've got is the accuracy. If it's a huge fiber line, they might want to make some other accommodation. So they can start that negotiation and process later and get that more detailed information. All right, what's the cost going to be to move this line versus this one, right? And if it's, this one is a higher capacity line, maybe we want to try and do some more engineering around that one and move this one instead where we can't do that. So the standard allows that you don't have to collect all of that information. And what we're really trying to get is, what type of utility is there and where is it? But all of that other information doesn't necessarily have to be exchanged with everybody else, right? You don't necessarily want them knowing the fiber count in that conduit, right? But it's nice to know there's something there that's communication maybe. So, and the MDT system does have that data sensitivity field, so it can be marked as sensitive or not sensitive. And if it's not sensitive, they have to do I think if it is sensitive, they have to do a further request to get that information.
Those are good questions.
Are there any more questions for Phil and Eric? Going once, going twice, gone. Gentlemen, thank you so much for your presentation.